Hello, physical science. I hear some people would like for me to go over the questions on page 217, and I'll be happy to do that for you. Okay, so let's go over these. These are the ones that I assigned, I think, yesterday. And since I'm going to go over them, if you haven't already turned them in, it's okay. I'm not going to count them because I'd rather you go ahead and do the worksheet that I gave you. And again, if anybody has questions after we do this, then please shoot me a remind message, and then we will go from there. Okay, so the ones on page 217, these are 217. All right, so it says an aircraft travels 1,000 kilometers west and then travels 500 kilometers west. What is the total displacement? Okay, so we're going to draw it out because that makes it the easiest way to do it. So west is that way. So west is that way. So we're going to go with 1,000 kilometers west. And my line's not very straight. So we're going to say that's 1,000 kilometers, and you don't have to measure it. You just have to draw the line so you can tell what's going on. Okay, so we have 1,000 kilometers west and then 500 kilometers west. Well, this is west, and the direction we're going the second time is west. So we're just going to keep going. And we're going to do about that much and let that be another 500. My line's very crooked. Okay, so I'm sorry, that was 1,000 kilometers. And this is 500 kilometers. Okay, so in this instance, your distance is going to be the total amount that you actually travel, which is 1,000 plus 500. So it's going to be 1,500 kilometers. That's your distance. Your displacement is where you talk about direction. Okay, displacement, you started here and you ended up here. So you are 1,000 plus 500, 1,500 kilometers from where you started. Okay, so your displacement is also 1,500 kilometers. And that's west because you're west of where you started. Okay? Now, number two, a vehicle travels 60 kilometers north and then 40 kilometers south. What is your total displacement? Okay, so you're going 60 kilometers north. So let's start with that. And like I said, you don't have to measure anything. But let's go with 60 kilometers north. And then we're going to go 40 kilometers south. So we're going to start from here. And we're going to go down 40. Down here. And that's 40 kilometers south. So the total distance is the distance that you traveled. I know it's not asking for distance, but I want to make sure you know the difference. Okay, the total distance you traveled is 60 plus 40. That's your distance. But it's asking for displacement, and you need to know how far you are from start. And that's going to be your displacement. Okay, so this is where you ended up. So if 60 minus 40 is 20, so that's going to be 20 kilometers from here to here. Okay, so you have 60 total, you came back 40, you have 20 kilometers from start. Okay, now what direction are we? Well, this is north and this is south. So I went north 60 and south 40. So I am still north of start by 20 kilometers. Okay, so that's what you're looking for. And let me circle that one too. So you're looking for 20 kilometers north. Okay, so the easiest way to do these, guys, is just to draw them out. All right, let's look at number 3. And again, if you need to stop and pause and, if I'm going too fast, just pause it and you can take a look at it. A boy walked 100 meters forward, then 150 meters backwards. What's his total displacement? Okay, so forwards, he went 100 meters. So this is going to be forwards. And this is backwards. All right, just, you don't have to label it like that, but just to make sure we know what's going on. Okay, so we're going to start from here. And we're going 100 meters forward. Okay, so let's go about right there. That's 100 meters. And that's not 10, it's 100. And that's forward. Okay, and we're right here. That's where we ended up. And then 150 meters backwards. And I have drawn myself into a problem, but let's go with this. So we can go, that's still your start, and we're going to go 150 backwards. And that's where you're going to end up. Okay? So you have 100 meters forward, 150 backwards, and so you are here. Okay, so we're looking at distance is the total traveled. So 100 plus 150 is 250. That's your total travel. That's your distance. But it's asking for displacement. So I started here, and if I come back, that's 100, and then this is 50. So I am going to be 50 meters, and it's going to be backwards. Okay? Because you went past where you were 50 more. And that backwards that's the direction. Okay? Now, let's go on the back for the next one because it's a little bigger. This is one of the ones that we were talking about before that looked like a triangle. So let's look at this. You've got an airplane flies 800 kilometers east. Okay, so let's just make our little 800 kilometers east. Okay. Okay, so we started here, and that's where we went, 800 kilometers east. Then 600 kilometers north. Okay, so let's go north. Hope that's going to be straight. We're going 600 kilometers north. And this doesn't have to be to scale. You're just drawing it so you can figure it out. Okay, so I want to know the total displacement. Now, you're looking at the displacement from start. Okay, you want to know how far it is from here to here, not how far you traveled. So it's going to be a little bit different. So what I want to do is find out what is the distance here. I want to know how far I am from start to right here. Okay, and I'm sorry, that was 600 kilometers north. Okay, so this is where we're going to use the Pythagorean theorem. And if you remember, the Pythagorean theorem is a squared plus b squared equals c squared. Okay, so you can choose either one of these for a and b. Okay, either one of these can be a and b. So let's make 800 a, and you have a square, so it's going to be 800 squared, and b is going to be 600 squared, and then your c squared is going to be your answer. Okay, so that's how you're doing the Pythagorean theorem. Now, so we want to make 800 squared plus 600 squared, and then that's going to equal to, 800 squared plus 600 squared is going to equal to c squared. Then you're going to square c, and then c is going to be equal to 1,000 kilometers. Okay, so let's look at, let me grab my calculator so we can go back through the actual numbers. All right, so 800 squared is 640,000 plus 600 squared is 360,000 . Okay, so that's going to be equal to 1,000,000. Okay, that is c squared. Okay, so this is a squared plus b squared equals c squared. But we want to find c. Okay, so c squared, you're going to take the square root, which is 1,000,000. You're taking the square root of 1,000,000 because that's your c squared. And the square root of 1,000,000 is 1,000. So that is 1,000 kilometers. Okay, and that's what we had up here. So what that means, you went from here, 800 kilometers, you went 600 this way, you used the Pythagorean theorem, and now this is 1,000 kilometers from start. Okay, so this right here is 1,000 kilometers from start. Okay, we'll pull that down just a little bit more so you can see it again. Okay, so that one's kind of long, but that's what's going to be on your worksheet. Okay, so let's do one from the worksheet so I can get you started on this. All right, so on the worksheet, you have number 1, an airplane taxis down the runway at 150 meters per second horizontally. So the lines, when you're doing these calculations with vectors, they don't have to be distance. They can be any value. So this one is going to be speed because it's meters per second. So I want to know what the resultant velocity. So if I go 150 meters per second horizontal, then I go straight up 30 meters per second, what is the resulting or the resultant velocity? And resultant is another name for hypotenuse. Okay, this is the hypotenuse. News, because I can't spell, and resultant. Okay, those are the same thing. All right, so let's look at this one. We have the airplane taxis down the runway at 150 meters per second. Okay, so it doesn't really matter how you draw this as long as you're drawing straight lines. So this is 150 meters per second. Okay, there's not distance, it's speed. Now, the plane is going up, straight up, at 30 meters per second. Okay, I want to know what the resultant velocity is. Well, resultant, we just said, is the same thing as the hypotenuse, which is this line right here. So let's go ahead and draw this. And I want to know what is my resulting speed or the resultant. Okay, so I want to know what this is. So we're going to do the same thing we did before. You have Pythagorean theorem is a squared plus b squared equals c squared. So your a squared, we can choose either one. So let's go with 30 squared plus 150 squared equals c squared. Okay, so let's put our numbers in. You've got 30 squared is 900 plus 150 squared is 22,500, and that's equal to c squared. Okay, so we've got 22,500 plus 900 is 23,400. But that's equal to c squared. You've got to remember to take the square root. Okay, so you're going to take the square root of both sides. And c, we'll put it up here just because I don't have space. You've got 23,400. I'm going to take the square root. And we're going to round off our decimals. So this is going to be 152 point. Let's go ahead and just make it 152. Okay, because it's 152.97. So let's go ahead and round that to 152, and that's meters per second. Okay, so that's going to be 152 meters per second. Okay, I'm going to give you a second to take a look at that again. If I'm not giving you long enough, go ahead and pause it so you can look at it. Now, I want you to go ahead and do the rest of them. Send me a remind if you're having a hard time with one of them, and I can give you some hints. Otherwise, go ahead and try to do the rest of it. And I think I had these due on Monday. Make sure on RenWeb, but I think they're due on Monday. But go ahead and work on these, and then give me send me a text message if you still have problems with it. Okay, hope you guys are staying well. We're doing good here. So A-okay. All right, you guys take it easy. Bye.